Hello there, Mr. Sutton here with the Pre-Cal Honors 8-2 Part 2 homework solutions on sigma notation. For this problem, they want us to find the sum, or if it's infinite, write the first four terms. So with sigma form, we're going to start with our lower limit of summation, which is 1 in this case, and we're plugging that in for n. That's why the n is written down here. So we're going to have 5 times 1 times x, and then we do all the integers up to 4. So 5 times 2 times x, 5 times 3 times x, 5 times 4 times x. And we simplify this if we can. So just writing out what we have, this is 5x, 10x, 15x, and 20x. These are all like terms, so we can actually combine these to get, let's see, we got 15x plus another 15x plus 20, a grand total of 50x. For this problem, we want the sum from -2 to 2 of absolute value of 3n. So we're basically taking all the integers from -2 to 2, plugging them into this, and adding all of those things together. So for our first term, we've got 3 times -2, or -6, inside an absolute value, plus 3 times -1, or -3 absolute value, plus, well, 3 times 0 is 0, so just absolute value of 0. And then we've got 3 times 1 in absolute value, and 3 times +2. And that's our last one because that was our upper limit of summation. So now we just have to simplify this and add everything together. So this is going to be +6, +3, 0, 3, and 6. So let's see, this is 9 plus another 9, gives us a grand total of 18. For this one, we want the sum from 1 to infinity of 1 over n. Now, since this series is infinite, we just have to write the first four terms. Let's get that right off the bat settled there. So starting with 1, we've got 1 over 1, which is just 1, plus 1 over 2 is the next integer after 1, plus 1 over 3, plus 1 over 4, plus ... to show that this is going on to infinity. For this one, we're going to take all the integers from 2 to 60 and plug them in here and add it together, or we're going to try anyway. So we've got 2 times 2 for that first term, and then 2 times 3, or 6, plus 2 times 4, which is 8, plus, well, there's an awful lot of these between 2 and 60. So I'm just going to skip to 60. So we're going to do plus ... and then plus 2 times 60, which is 120. So now I'm just going to try to find a clever way of adding all these together. Now, since we're adding 2 each time to get to the next number in the series, this is an arithmetic series, common difference of 2. So we can actually use our arithmetic sum formula. That was n times a1 plus an over 2 to add all these together. So we have an n value of, let's see, from 2 to 60, that's going to be 59 numbers. So 59 for n. A1 was this first term of 4. AN was this last term of 120. So plugging all of that in. 59 times 4 plus 120 over 2. Let's use the calculator for that. And if I plug that in, it comes out to 3,658. For this problem, we're going to plug all the integers from 0 to 25 into this expression here and add everything together, or at least that's our goal. So we've got 2 times 3 to the 0. 3 to the 0 is just 1, so that's just going to be a grand total of 2. Next, we've got 2 times 3 to the 1, which is 6. And then 2 times 3 to the second power, 2 times 9 is 18. And then, well, we're just multiplying by 3 each time, right, to get the next term. There's an awful lot of these between 0 and 25, so I'm just going to kind of skip to 25. We're going to have 2 times 3 to the 25th, whatever that is. And I'm going to write a plus ... plus to show there's a whole lot of terms that we just didn't bother writing. So clearly writing all these out and adding them together is going to be a bit of a chore. However, this happens to be a geometric series. You might have noticed that common ratio of 3. Since it's a geometric series, we can use our sum formula for a geometric series. That's a1 times 1 minus r to the n over 1 minus r. Hopefully you have that memorized by now. So we've got an a1 value of how much? Well, that's just our first term, which we conveniently already wrote out up here, so that's 2. Next, the r value, that was our common ratio of 3. If you do 6 divided by 2, you'll see it's 3. You'll notice here that the only thing that changes is we multiply by another 3 to get the next term. So common ratio of 3. And now for n, how many terms are in this series? If you're going from 0 to 25, that's a total of 26 numbers, right? You've got 1 through 25 and then 0 as well. So 26 for n. So plugging all of this in, we've got 2 times 1 minus 3 to the 26th over 1 minus 3. Now it's time for the calculator. And it looks like all of this craziness is going to come out to a big number, 2.542 times 10 to the 12th. On this problem, we're trying to express this series in sigma notation. So we have our sigma, and by the way, we notice these are all multiples of 4, 4, 8, 12, 16, 20. So multiples of 4. So we've got sigma, and to express multiples of 4, I should just write 4n as my summand. 4 times whatever gives you a multiple of 4. Now we're starting at 4 times 1 here, so that's n equals 1 is our lower limit of summation. And we're going, there's 5 terms, but this is also 4 times 5 is really what tells us that 5 is our upper limit of summation, and this is our final answer for this one. That's all you needed. On this problem, we want to write this series using sigma. So we need to find a common tie between all of these. We've got 1 over 2, 1 over 4, 1 over 8. We're doubling each time here, or halving, I guess, depending on whether you're looking at the whole thing or just the denominator. These are all going to be powers of 1/2. That's what ties all of these together. So when I write my sigma out, my summand here, I'm going to have 1/2 to the n power. Or I could write 1 over 2 to the n, also comes out to the same thing. So what's my first thing going to be down here? What's my lower limit of summation? If 1/2 is the first number, that means I must have 1 over 2 to the 1, or n equals 1 is my lower limit of summation. Over here, well, this isn't the last term, right? The last term with this dot, 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 is actually infinity, so that's actually easy. I'm just going to write infinity as my upper limit of summation. For this one, we're trying to express this series using sigma form. So I'm going to start with my sigma here. And to get this pattern, to get a summand that gives me these, I've basically got x to something over the same something. It's the same number each time. It's just this number keeps going up by 1 every step you take to the right here. Since I have x's in my expanded form, that means I need an x in my summand, and I need to make sure that my index variable is not x. I don't want to plug anything in for these x's. I just want them to hang around. So for this, I'm going to write x to the n over n as my summand, and now I just have to pick a lower limit of summation that gives me 4 in the beginning. How about n equals 4? Yeah, that'll work. And then we notice that there's this plus dot, dot, dot here, so this is actually an infinite series, meaning I'm going to make infinity my upper limit of summation.